Good morning. So today is something a bit different from usual. So it's gonna be live coding. So I grabbed a problem from a platform that I really like, which is Code Wars, and I picked up fairly interesting problem, which is data transformation, and it's a bit long. It's nearly an hour, so it's a bit different from the other videos, but at least you can see how what's the thinking process to tackle heavier problem. Let me know in the comments what you think, if you like it, and happy coding. So the kata is called address book by state. So given a string with friends to visit in different states, so it's a string with the name of the person, the address, the city, and the state. We want to produce a result that sorts the name by state and is the name by state followed by the name of each person residing in that state. Okay, so then from that list of people, we want to build like an address book by state. So you've got Massachusetts here and Virginia, with Alice from here and John and Sal from here. Okay, so there's a caret here. Spaces not always be seen in the above results. Caret means a white space. Okay. The result sigma when unprinted. Okay, so that's when it's printed, and that's the raw string. You can see the escape character here, depending on the language. Okay, so that should be fine. There can be a blank last line in the given string of address. That's fine. The test contains only those for states, so it's a finite list of states, so no surprise. You can see other example in the sample test. That's fine. For the lazy one, okay, so that's the dictionary of the state code and the state. That's fine. So basically it's a transformation exercise. So we've got a list of person and we want to parse the data and then building something more meaningful for another consumer. All right, so so that's blank. That's us to implement, and that's the test cases. So we've got one fixture here and a second fixture here. Do test. So the do test is just invoking the function here, the answer, and then comparing the answer to the expectation. That's fine. So what we can start doing is just to copy paste that one and putting that here, and then copy pasting those here. Oh, sorry, that was just a blank main Go application. So then if we want to naively replicate a simple test case, we just do we can just log print if I'm invoking the function with the fixture, is it equal to the expected answer, the expected solution. That's it. No need to spin up heavy framework. That should do it. So then here it won't compile, so then we are returning a blank string, and if we run that, false. Okay, yeah, so basically empty string is not equal to that one. All right, so okay, so let's start parsing the raw input. So what we're gonna have to do is to get the name, to get the address, and to have a kind of lookup for the state name based on the state code, like VA for Virginia. So in the instruction they were giving the map, so that's fine. All right, so let's start parsing the structure. So so we are getting a string, so then you can see that they are just separated. Each record, each person is separated by the other by just a line breaking. So I think we can go simply like people, then using the string package with split, and then what we want to split is the input string, and the separator, as I was saying, is just the delimiter here. So we can have a look to that one. So let's print out people. Sorry, I should keep that to make the function compilable. Running that again. So we've got, okay, that's not really easily readable, but we can try a for loop. So a range loop. So then we are looping through the people, and then we just print. So then let's run that. All right, so we managed to parse to get one line per person, so all good. All right, so the next step for us is obviously to extract the meaningful name, separating the different elements, so then to reconstruct them. So I'm just gonna mute the sound. All right, so let's define our structure. So it's gonna be a person. The person has a name. The person has an address. The person has a city, and the person has a state. Okay, so let's populate that one. So then we're gonna say, so this one can be called raw people because it's just pure raw string, and then we can define a slice of person. So people make so a slice of person of the length of the raw people. So in our case here it would be 3, so we're gonna make a slice of size 3 of person. So then we're looping through our raw people, and how are we gonna extract those information? So we can see that there's a logical separation splitter with the comma here. There's just slightly difficult thing is that the city and the state code are not separated by a comma, so that might be problematic. What sounds quite obvious here would be to use regex, which would be a straightforward regex. So sorry, thinking loud, if we would go that path with the separation with the comma delimiter, we would go string split exactly like that, but we would go with split, so the raw person, and then the delimiter would be that. The problem with that, if we, sorry, not the problem, but an alternative would be here. I'm just gonna do range log. So I'm just gonna print each field, and I'll explain something. All right, if we run that, so you see that for John, we've got John here, we've got the address, and we've got the city and and the code state. What we could do for the last one, so for x, so that's x0, sorry, that's the slice of a splitted string. So that would be E0, E1, E2. What we would have to do is E2 and then maybe just grab the last two characters, for instance, to get the state code, like that. So then it would mean that the city would be something like E2 and then everything except the last character. So it would be something like length of E2 minus 2 and the whole string. So you see that it's highly unreadable and it gets confusing, and as it's live, you see that I didn't bother to give a meaningful name here, but it would be much cleaner to go, much powerful and maintainable to go for a regex solution. All right, having said that, let's copy that that record. Let's copy John and let's go on regex online. So that's regex online. So let's select Goland. That's our regex that we want, the test string. So what do we want? We want to use capture group. So then we have different elements available. So the first group is any character really with multiple occurrence, and the signal to say that it's the second capture group is going to be a comma. So we can just do first capture group, any, in multiple instance, and then divided by a comma. So you see that it has matched John and the address. So if we keep carry on, we can say second capture group, any character in multiple occurrence, and then carry on with the city. So then anything multiple occurrence, and then you see that we've captured group 1 John, group 2 King Road and Plymouth. So if you I'm just gonna zoom a bit. Right, so if you have enough if you have an eagle eye, you can see that there's a space here. So regex can solve that for you. So it's precisely a comma and a space. So now we are nicely capturing the name and the address. So how to solve that with regex? So then we would just say that the city is separated from the postcode, and the postcode, sorry, not the postcode, the state code, it's simply as, so it's another capture group, but this time it's any character uppercase in exactly two occurrences that we are looking for. So then you can see that it has cleanly captured the city and the state code basically. So that's our regex. No need to have any starting or ending flag for now. So we'll go with that. We can try another one to be sure. So let's try Alice, for instance. So Alice, the address Richmond and Virginia. So all good. So we're gonna try this regex. Alright, so the way it works, you have to compile a regex. So let's call it R as regex, and then the package regex is regex p, and then we say must compile. So must compile will panic if the regex is incorrect, and I just copy paste the regex that we just developed. All right, so in order to get the capture groups, what we the function we have to invoke on that instance of regex is I think it's find string submatch, find string submatch, which is taking a string, the test string, and then spitting back a slice of string. So let's see what we are getting there. So here row people, so here I can say row person, and then we can send row person, which is a string. If you recall, row people is just a slice of string. And then we can I'm just gonna do submatches like that. Oops, typo. Submatches, and then let's just print each submatches. So then range submatches like that, and then s. So let's see what we have. Right, perfect. So you can see that it has printed the whole string. So then it means that this thing is sending back you a slice of string, and the first element is the original string. That's fine. So so then what we can do is to start building our data structure. So our person will be person unused. Okay, it might conflict with the name struct, so we can call it p, for instance. So the name will be my submatches, as I was explaining to you. 0 will be that one, so then it will be submatches 1, and then submatches 2, submatches 3, and submatches 4. So what we can do here, we can just print the person. Alright, so quick tip, what you can do here, we can't see very much the name of the field. So if you've been watching the video so far, this is nice trick when you're using print format, where you use %v for value, but then if you do plus and the object is a struct, you're gonna have the name of the field. Alright, so we have name John, address the King Road, and city Plymouth, and state Massachusetts. So that's really good. If we keep an eye on what we want, MA for Massachusetts needs to be translated into Massachusetts. So if you recall, the code, the kata was carrying you giving you the dictionary, so we can build a dictionary. So var, we can call it state code dic for dictionary, and we can say it's a map of string, and then we can copy paste. Alright, so in Go it's double quote, not single quote. So then we're gonna do a replace. We want to replace, hold on. So for that selection, we want to replace the single quote by the double quote, replace all, and we have our dictionary. Alright, so then so here it's the code. So then what we can do is to do invoking our dictionary with looking up with the code. So if we run that again, we have MA map to Massachusetts, VA to Virginia, and so on and so on. So all good. So it's pretty elegant, as you see. It's really compact to decompose the raw string into a strongly typed data structure. So I'm happy with that. At the moment, we're looping through this slice of string, but we're not doing anything. So what we have started to build like this slice of person. So then simply, if we use the index in the range, what we can say here is that people at the index I will be that data structure. Okay. Right. So we've read so far. We've read this raw input and translated into strongly typed unreached data structure. Now, what we have to do is to start building the output. So if we have a deeper look, so they want actually it was better on that view. So state ordered, alphabetically ordered, and then the people alphabetically ordered by the name as well. All right. So somehow we need to find which person is in which state. So that's where we are gonna construct the address book logic. So all right. So then, which kind of data structure we could build to hold people by state? So I'm instantly thinking about building another map. So then you would have a map of the key would be the state, and the value would be a slice of person. Let's try that. Let's see how it goes. So then we want a state person, a state people actually, dictionary. So then it's gonna be a map of string, the name of the state, and the value, as I said, slice of person. All right, let's fill that. So I need to loop through people. So you could argue that it can be in terms of complexity if people is a slice of 10,000. I'm gonna loop through 10,000 again, so doubling the complexity. But you should aim to have a working piece of software first, and then optimize afterwards. So here I'm having said that, I'm just gonna loop through the people slice. All right. So then I need to get so a person has state, right? I need to populate, if let's say in the map Massachusetts has already got John, I want to get that slice with John, and then I just want to happen with Mary, for instance. So I need to do people in state, which is gonna be state people dictionary, and then the state of the current person, and then because that person belongs to that state, I need to add that person. So we can say, you can say that updated people in state would be the people in state already plus that person, and then that's the updated people in the state, and then I just need to update my map. So state people dictionary, and then with person.state, then I'm gonna replace that by oops, sorry, I forgot here. I need to declare it before prepending it. So then it's gonna be person like that. I need to alright, I tried to do not mutate that people in state, but you see that it's involving a lot of boilerplate and initialization. Like, I can't append something which doesn't exist, so then I would have to make something like make to initialize that slice. So gonna choose people as type. Alright, so what's the type of so that's an array of person, missing length argument to make, yeah, so I have to do that, and then it's complaining to me that person is not a type because there's a clash here with the name of the variable and the name of the struct. So let's change that to p, to p, and then here p, and then here that's my person. Right, a bit of boilerplate, not simple. What we could have been doing is just directly mutating the people in state, basically. But let's try that. Let's have a look to that dictionary actually. So if we do for key value range the state people dictionary, and then we log the key, and then we log the value. So the key would be the name of the state, and the value would be the people in the state. Let's have a look to that. So in Massachusetts we have John and Sal, and in Virginia we have Alice. So all good. Fine. So so we have the state and we have the people in the state. So now we just need to build the output, basically. So building the output. All right, we can start with the people. So the people, if we go back here with this array of people within a state, so it's just a string formatting, really. So you have 5 dots, and then the caret means space, so 1 space, then the name, space again, and then the address, then the city, and then the unreached state. So so basically we need to loop through each state, and then we're gonna loop through each people. So how can we loop through each state? We do have a dictionary here. So then if we do for the key, just for the key, and we are looping through the state called dictionary, Right, so obviously here there's for instance there's nobody from Indiana, so we've built a state people dictionary before. So what we could do, syntax for the map, we can say if the people, hold on, am I gonna have a clash? Yeah, I'm gonna have a clash. So people in state, okay, and then we are looking up through the people that dictionary with the key. So then it's getting confusing. So K is actually the state code. Right, so we don't want the state code because we built with the state value. So then we would say we're gonna ignore the key, and then we're gonna say state, and then we can look up by state. So typical map syntax, so you can overload the lookup with an OK function, and if it's found, it's gonna be a boolean equal to true. So then if it's found, I want to execute a logic, otherwise it's simply gonna be ignored in the range. So people in state, so we can just have a look actually to see what we get from here. So if I'm log print that, alright, we've got a first array which was from Massachusetts and a second array from Virginia with both the two person, so excellent. So then we want to format each person into this kind of string. So right, so we're gonna have to loop through them. So it's gonna be dirty. You can see that we're already in the third level of nesting, but we can refactor afterwards. So then for each person, I'm gonna say P to do not have a clash with person struct here. So for each person in the state, I want to format it. So then what we can do here, it's already dense, so we can craft a little receiver function. So for a person P, we can call the function toString, and it's gonna spit back a string, and we can say that so we're gonna need the name space the address, the city space, sorry, 5 dots before. So that looks like the opposite of string split. So this is a string join. So we can return strings join. So we said 5 dots. Then the name, so p dot name, then the address, p dot address, and then p dot city, and then p dot the state, and we can join that with a space, right? So if we have a look to that, if we say p dot oh, I forgot range here, range p dot toString here, we can just log print that to double check what we're doing. Alright, so that looks alright, John Daggett. Okay, so we have our people formatted, and then if we go back to what we want we want to first start with the name of the state. So let's build it's like a state holder, right? State addresses. Okay. So when we are at the when we're looping through by state, we want to say we want to create a slice of strings. So it's gonna be state addresses string, and then we can say we can simply say var and then string, and this one starts with state addresses by the name of the state. So then state, and then once we have our people, we can add our people in. So here we can have state address and then do the same thing, state address, and adding the people. Okay, so let's have a look after here. Let's have a look to what we get for a state addresses. So it should be 2 lines because we have 2 states. Right, so then here Virginia is correct. With Alice, Massachusetts is correct as well, but you can see that there's a tiny mistake here where we are looping through the state where there's nobody. So it needs to be after that statement, that control statement, like that. So then if we print that, let's have a look. There you go. So Virginia, Massachusetts, all good. Okay, so I just noticed that Virginia is coming before Massachusetts, so that's something we need to sort. Let's do that now. So I'm going through this dictionary, and obviously as you loop through a dictionary, the order is not guaranteed. So you see that Massachusetts came fine, but if I keep running it, you see Virginia coming first. That's the nature of the maps. So a map is not tailored here for that operation, so we need to build an array, an ordered array of state. So we can call it sorted states, and it's an array of string. So for that we're gonna use we can simply collect the name of the state from the dictionary above, from that dictionary, and just collect the name and then sorting them. Alright, so for that we don't need the key, but we're interested in the value. So range the state code dictionary, and then we can just say, alright, you can do better here. You can allocate the precise size for your slice, so the length of our state code dictionary. So then here we can use that's a map, so we can't use. So my idea was to do sorted state and then like that, as we would do when we loop on a slice, but we can't because we are looping through a map here. So then rolling over, so var sorted state string, and then we'll just have to mutate, unfortunately, that slice. So then as we already seen, append the sorted state with the name. Right, so now we can just so that's just a slice of string, and then we can just use sort.strings on that one. It's gonna mutate that string. So as usual, we can have a look. Sorted states. Alright, so they are sorted, and then we have, so then that was sorting the states. Right, we can't loop through the dictionary because the inconsistency we saw, so then we have to loop through these sorted states, and let's have a look. Right, Massachusetts first, and it should be consistent now. All right, so the other requirement is that the person are also sorted by alphabetical order, people's names sorted. So here that's unfortunate because John is going first and then Sal second, but we can try let's call it Zal. So you can see that Zal would add up first, and then John, and then Sal. So that's an edge cases which the test is not covering, but you would, in a professional environment, you would catch up that with more thorough tests. So let's sort that. So it's happening at this layer. So when we're retrieving people from a given state. So we're gonna do the same trick. So here we are starting our slice by the name of the state, and then we are looping through the people. So here, just before looping through the people, we can make a copy of people in the state and calling it sorted people, just sorted people actually, which is a copy of people in the state, and then sorting it, because the sort package is mutating the original slice, as I said. So here is not as trivial as just sorting a slice of strings, because we are dealing with a slice of person. So for that we need to use a slice table, and slice table you are just giving the slice to sort, so the copy of people in state, and then a function. You have the signature just above my ID is helping, so it's a function which is taking two integer, so inj, and giving back a boolean. So we want to sort them based on the name, so what we can do is to do return so sorted an element I is inferior to the element j, but based on the name. Right, so then once we've sorted them, we're not looping from the unsorted, but we're gonna loop on the sorted one. Alright, let's have a look to that. Alright, John, Sal, and Zal. So all okay. So if I'm putting back the fixture as it was, because our bullseye is still on passing that test. Okay, Right, so we've got our array for state. Let's so we can merge them. So here we need to concatenate that array. Sorry, not concatenate. We just need to join that array to build that part of the address book. Massachusetts off to Virginia. So and then building that block, and you can see that each block is better here. Each block is separated by breaking line and a space. So we need so we've got state addresses, and we want the book, basically the address book. So then we can say for address book string, and then state address, and here instead of log print that one, we want to add that to the address book. So address book, append the address book, and then this is where we're gonna join the state addresses. So I want to join my state addresses. Here you can see that it's only joining them by just a line break. So we're gonna do line break, and then so we can just print the address book, doing step by step. So address book. So my address book should be only 2 elements. Alright, so you can see that the address book is I mean, you can't see very well. Hold on. So for range address book log, so right, so that's the first element, and that's the second element, and we're gonna glue them together as we did with the string join, but this time, as I said, it's they are separated not only by a line break, but a line break and a space. So then we will have to do actually that's our final address book, so we can do strings join address book, and then line break and space. Okay, so we've got false here, so it means that something didn't go as expected. So let's just extract address, so we can say final address book equal that bit, and then returning it, and then we're just gonna log it. So find address book. Okay, Virginia, what was expected? So John, Sal, Alice, Massachusetts, Boston. Okay, so here I can see 2 spaces instead of 1. There must be an error somewhere. It may be when we, yeah, here. So copy paste error. So here it's gonna join them by adding a space, but here I did a space, so I'm removing it. True. So our test is parsing. So then I can remove that thingy. No need to debug. Alright, so let's try with the other fixture, the bigger fixture that they were providing in the code challenge. So AD0 and AD0 solutions. So then if we do AD0 and AD1, True. So all right, so the code is parsing. So if we try to refactor a bit. All right, so we are meeting the requirement, and let's try to refactor a bit. So the function is not too big, 30 to 80, so it's 50 lines, and it's not bad at all actually. But we can improve readability by extracting different pieces of logic into functions, for instance. So we can do the first one, for instance. So we are parsing the goal of this operation here from the input string is to get a slice of person. So then we can do that. So then function, so then to people, so then it's getting a string and it's giving you back an array, a slice of person. So then if we do that, so then we just send back the people, and then we can invoke that here. So we can have people to people and then string. Then address book logic. So here we built a dictionary, state people dictionary. So then we can say we can extract that as well. There's no, so it's from a slice of person. It's building a map. So we can say func. So we are building a state people dictionary, simply like that. From slice of person, we are sending back this map. So then we can just return the map like that. And then here we can say the state people dictionary, which is taking people previously built, and then state people dictionary like that. Okay, so it has shrink our function, which is now readable on one go. So then address book logic, building the output. So here what's going on, we are just getting the sorted state. So we can say function sorted state. What do we need actually? We need the state code dictionary, which is that thingy. So then state code dictionary, and then it's giving you back a list of sorted state, and then we can just grab that and then return sorted state. So you can see here it's a nice refactoring, because the mutation is occurring only on that function. So that function is not transparent in terms of functional programming, but we just remove that aspect, that dirty aspect, from the main. So then we have sorted states, and then from the state code dictionary. Right, so here we can rename that one with an S as well. Let's try to run. I should have run each time I refactored. Right, still parsing. And then here, what's going on here? It's just building the address book, right? We could have extract that, or we can simply extract that one to its own function. Yeah, let's do that. So basically this one is the address book, which is just a string. So let's brutally put that in the function and then just filling what it's required. So that's a slice of string. This one is just a map of string and people, and that's it actually. So then if we invoke that one, we can just return it directly actually. So then sorted state and then state of people dictionary. Right, so our main function is now just a bunch of lines, and then it's pretty clear what we are doing. You saw that, and that's not super nice here. Map string person that we are reusing at some places. So what you could do is to do type, and we can say state code people or something like that, and you could define that person, and it doesn't need to be public, so we can do like that here and here, and okay, so yeah, I have a public here, so then it's complaining, that's fine. And here, let's try that, and it's still passing. Alright, so I hope you learned some stuff, and what I really wanted to do with this kind of video is how you think and how you tackle, you break down a problem and put your Golang knowledge into life. So if you enjoyed the video, please like and subscribe, and let me know if you would like to see more of those kind of live coding. I know it's a bit long, but I'll see if it's working. So thanks for watching, and happy coding.